had the most boredest thing today. Like seriously, I'm just completely bored and have no idea what to do. Like, I wish there was something cool to do. Something super cool to do. Did somebody see super cool water? Super cool, what? You know, where water is in a liquid state, super cold, and once you move the molecules, the water molecules, it becomes a solid. It might cure your boredom. Then what are we waiting for? Look, we should make super cool water! Hey!
So, super cool Adrien, you wanna teach me how to make that super cool water now?
So, in order to perform this experiment, what you need to do is have distilled water or purified water. This is both the same thing. It's okay. The reason why we need distilled or purified water is because without it being distilled or purified, there's still going to be little minerals or other unfiltered things that the water molecules will be able to attach to, which will then cause the water to freeze. We don't want that to happen because we want to see it super cooled, right? So once you have your distilled or purified water, what you're going to do is put it in a plastic container, so it won't freeze the glass. And you're just going to put it in the freezer. It's the easiest way, and then just give it time to cool down. Because I have this sort of small size, it only takes about an hour to an hour and a half for it to be super cool. Actually, yeah, for an hour and a half to an hour 45 minutes to be super cool. So make sure that you're messing with your dimensions. So like a regular sized water bottle should be like about 2 to 2.5 hours, and so on. So yeah, this size matters. I just said that.
Hey yo, super cool Adrien. Since we have all this spare time, how about you tell me how supercooling works? To explain supercooling, we need to first recognize the properties of liquids and solids. So liquid is a form of matter that has molecules that aren't bonded to each other to be able to move around freely, except that they have a definite volume compared to a gas. Solids, on the other hand, are vibrating bonded molecules that have a definite volume and definite shape. Water is a weird molecule. That's because although it can go either solid or liquid, it has a weird transition in between. As shown by the phase diagram, the transition from solid state to liquid state produces a negative slope, which is due to water's bonding properties. Because of water's bonding properties, although it is below 0 degrees Celsius, there is still a chance that water can stay in its liquid state. This is called supercooling. With supercooling, water is able to stay in a liquid state below 0 degrees Celsius because of its molecules and their misalignment. You see, in order to form a solid, the molecules bond in a specific way in order to create a certain structure that keeps it in its solid state. Because of water's misalignment, the molecules aren't able to create this solid state, therefore maintaining in their liquid position. By bumping, shaking, or mixing the water's container, we add kinetic energy into it. The liquid state then takes the kinetic energy and uses it to align and create the solid structure, therefore creating the quick transition from liquid to solid. So now that you finished explaining, what else can we do?
supercooled water. Yep, completely solid. Well, thanks, cool Adrien. Wherever you are. Supercooled water. Try it at home, kids. It's safe.